Good day, everyone. Today we are going to be tackling this system. What is the issue? It's an Acer laptop. One of our clients brought it and he complained that it's dead. And she said before it was dead, the charging ports, sometimes when you plug in the power, you discover that it's giving some spark, and then eventually the board stopped working. So today we are going to be troubleshooting what the problem is. We don't know, or we have to do some level of troubleshooting. So we have opened the system. So we'll just quickly remove some of the things we have opened from the system. Remove the top board, the top casing. Then remove some of the little things on some little attachments to the board, the screen, and then some of the connections to the Wi-Fi. So we can bring out the board, then also remove the power button, the power sockets. Now the board is removed, so we are going to troubleshoot it together, and by God's grace we'll get the problem. Now let's put this aside, then work on the board. Now this is the board. First thing first, we'll do some resistance check on the board. And if I say resistance check, what do I mean? You need to check the power rail, the main power rail. How does the main power rail go? Because it is from that point of power rail that we do our troubleshooting. That's the voltage injection that we use to get our that we use to put the voltage into the board. Now how do we start? Now let's check. This is the power, this is the socket for the power. Now first thing, check the multimeter is already put on a continuity. It's already put on, so these are grounds. All of these holes are grounds. They are grounds. All these are grounds. Now let's check the ground on the sockets. So there are two spots here. These two are the grounds, and why the second one is the 19, the positive terminal. This is the ground terminal. Why is the positive terminal? So it's polar. So now how does the positive terminal go? So it's passing through this coil. This is a coil, power coil. Then from this power coil, okay, if it's not coming through here, then let's see where it's coming through. It should land on a particular, it should be coming to one of the transistors behind the MOSFETs. These are the MOSFETs. It can be any of these ones behind. Let's check them. Let's check them. Let's check. No one. Okay, I can see it's coming here. Okay, coming like this. All right, so that's how it's coming. So it came here. So from here to these points, then to these points, yeah, like this, then to this. And this one goes to almost all the power to the board, on the board, but it goes to the ground because I think, yeah, the problem now is the main power rail is short to ground. You can see it's short to ground. Even this transistor is short to ground. Okay, it's not short, but the main power rail, output power rail, is short to ground. So we have done the resistance check. So now we need to use the voltage injection method to find out what the problem is, and we are going to be engaging a variable power supply made by me in one of my videos that I did in the introduction of tools. I've explained some of the equipment we use in troubleshooting and fixing power supply. Fixing issues on electronic board, particularly phones and laptop boards. So now we are going to be injecting voltage to this main board. So now let me connect the ground of my board of my power supply to it. Let me connect it to this, connect it. Okay, ground is connected. Now let's connect the terminal, then switch this multimeter to voltage session. So connect the positive to the positive, then the ground of the power supply to the negative probe of the multimeter. Now, now I'm going to be injecting with this positive probe. Now I'll need to connect my power supply to the. Now I'm using this. This is a stable, a fixed power supply. Why this one is a variable one? So I'm supplying from here into this, then I vary the voltage through this. So now I want to. The voltage is at around 14 volts right now, and then I think I'll need to just I want to reduce the voltage to like 5 volts. We are trying to see if we can get 5 volts. I think 5.8 is also okay. This is 5.2 now. Now let us inject these volts to the main power rail. This is the end of the main power rail. This is from this point that it gets to every part of the board. So now you can see that the voltage is going to 0.2 volts. So meaning that somewhere is being, something is consuming the power. Something is consuming the power, which we don't know yet what that problem is. Something is consuming the power. Let's check the other side of the board. You will discover that anytime I remove it, the voltage goes back to 5 volts. If I put it back to that point, it goes back to 0.2, meaning the 5 volt is being consumed somewhere. And it doesn't just get consumed. That thing that is consuming it will be heated up. It will be heated up. We'll feel some kind of heat when we have a feeling. We'll do a general feeling on the board. Feel the board. Is there anywhere that is heating up? We can't find anyone yet. I'm trying to feel everywhere. Now if you can't find that, that means probably the voltage is not enough. So let's increase the voltage to maybe like 10 volts. Let's give it like 10 volts this time around. So let us inject 10 volts there and see whether, okay, you can see a spark. Can you notice a spark? I feel a spark here. Now the voltage has gone to 0.4, more than the other time. So meaning enough voltage has been injected again, and the remaining is 0.4. So let us feel around again and see if anything is heating up. Nothing is heating up for now. We also check the other side of the board if anything is going to be heating up. Nothing yet. Let us increase the voltage, the current. This is the knob for the current to increase the current. So let's increase the current and see if we'll be able to discover that. I still not found it. Let's increase the voltage to maybe like 13 volt or so. Increase it. It's increasing. Now we have 13.2. And let's check. There might be a spark. Let's observe it. Okay, there's a spark, but it doesn't have that lightning effects like we had the other time, this time around. So I'm still trying to check. Let me check the other side. You will see now that the voltage that we have, it has dropped to 0.6, unlike the 0.2 and 0.4 we saw not quite long. Now we have, I can still not feel anything. I'm feeling some warm around here, some warmth around here. I don't know what is warming, what is that. Feeling some warm around here. Let me increase the currents. Maybe the one will come out very fast. The place is warm. Place is warm. I'm feeling it with my lips. Place is warm. I'm increasing the voltage. I want it to get to a point that I cannot touch it. That it will be this is very hot, too hot to touch. Let's check with some fuel. Some fuel. Now let us check. Let's check which one of them. There are many components here. We can see MOSFET, coil, capacitor, and some other small components around here. So which of them is heating up like that? So we'll see. Anyone that the fuel on it get dried up very fast is a problem. Now I can feel this capacitor. I can see this capacitor is heat. The fuel on it has dried up. This second capacitor here, this one, I can feel that. So now I think we have discovered the problem. Can see the culprit. That is the one that is causing that problem here. So it's the one that is causing that problem. Very hot, too hot to touch. So we'll engage our workstation to remove it. But before that, we just put some little soldering paste just to enhance the heat transfer on the board across the components so that the component can remove on time. Let me increase the temperature. Let me switch this off. This component is faulty. Yeah, it's removed. Now we'll check that component alone. Now we'll do a resistance check on the component alone and we'll discover something. Now we can switch off our workstation. Our power supply, variable power supply. Since it has finished, we have finished engaging it now. Before I said this place is connected to ground, it's short to ground. Let's see, is this short now? It's no more short to ground. There's no more beeping sound, meaning that it is not no more short to ground. If you can hear that sound, you heard the sound before, but it's no more. Now let us check this component that we removed. You see, can you hear the sound? You hear the sound from the multimeter showing that it is already short to ground. So that's what is causing that problem. It's one of the problems. So that's already resolved. Now we are going to couple back the system, and when we are done with that, we are going to return to test the board. Thank you. Now, while trying to couple back, we discover that the charging port has a problem. the ground of the charging port is already disconnected. Can you see? You can just zoom to here. Charging port, they call the ground to the charging port is, you can see the charging port. The back of it is just the positive terminal that is connected. The negative terminal is already removed. So we are going to quickly connect this back and come back to this video after we have finished coupling. Thank you. Now we have finished coupling the system. Let's test if all that we have done is now working. Excuse me. Now plug it in, then power the button up. You can see there's power, there's light here. Can you check it and check the screen? The screen is on. It's on now, so the system has come on. So we've been able to fix the power port, the ports, the port that got disconnected. So that has been fixed, and then the board also fixed, and now the system is working perfectly. If you have learned anything in this video and you like the video, please help us to subscribe to our channel. Click on the notification bell and let us have your comments. If you have any questions, maybe there's something that you don't really understand in the course of the troubleshooting and fixing, please do well to put that in the comment section, and we'll revert back to you. Thank you.